Okay, number 19. Okay, we need a second derivative sign chart. So first I'm going to find the first derivative. And the first derivative is a product rule. So I have x and x plus 3 to the 1/2. The derivative of x is 1. The derivative of this other one is 1/2 x plus 3 to the negative 1/2 times the derivative of the inside, which is a 1. Crisscross, and when you do it, also simplify it at the same time. So when I multiply these two here, I'm just going to write that as a square root. So that's the square root of x plus 3. Plus, when I multiply these guys, I have an x in the numerator, a 2 in the denominator, and this is going to move to the denominator. So I have an x in the numerator, a 2, and a square root of x plus 3. Okay, that is using the product rule. Now, since I don't want to do the derivative of this as it is to get the second derivative, now I'm going to simplify it. So to simplify it, I'm going to get a common denominator. So I'm going to multiply this first fraction by the same denominator as this, a 2 and a square root of x plus 3, a 2 and a square root of x plus 3. And this is still my first derivative. So keep my common denominator, 2 square root of x plus 3. In the numerator, when I multiply these guys, I'm going to have a 2 and the square root of x plus 3 times another square root of x plus 3, which is just x plus 3 without the radical, and then plus x. Now all I need to do is distribute and combine like terms. So when I distribute, I'm going to get 2x plus 6 plus this other x. So my final first derivative would be 3x plus 6 over 2 square root of x plus 3. So that wasn't awful. But now I have to do it all over again to find the second derivative. So this is very time consuming. So now I'm going to do the second derivative, the derivative of that. So now I'm working on my second derivative, which is going to be a quotient rule. So you might want to do the derivative of the top and the bottom separately. I can do the derivative of the top pretty easily. The derivative of the bottom, the derivative of this, 2x plus 3 to the 1/2. Let me just do that off to the side just to make sure I get that right. So I'm going to do a power rule, chain rule. So it's 1 x plus 3 to the negative 1/2 times the derivative of the inside, which is 1. So that derivative is just going to be 1 over the square root of x plus 3. So when I get to the derivative of the bottom, I'm going to write that. All right, so here we go doing my quotient rule. Low, d high. Well, the derivative of the top is just 3, so I'm going to take that 3 and multiply it by the 2 and call that a 6. Minus high, d low is this, so when I multiply by that, it's just going to put this denominator on the bottom. Draw the line and square below. Well, when I square this, I have to square the 2, which will give me a 4, and square the square root, which gives me an x plus 3. So that's my second derivative, but again, I just kind of have to clean it up, and this is not pleasant. Here we go. So I'm going to, since it's a fraction within a fraction, I'm going to get rid of the problem and multiply by this denominator, the square root of x plus 3, the square root of x plus 3, and the square root of x plus 3. Okay, what do we get? Okay, so this first term is just going to be 6 times x plus 3. In the second term, the square roots cancel. And in the denominator, I have a 4 and an x plus 3 to the, since they're both x plus 3s, this is to the 1 power and this is to the 1/2 power. So we add those up and we get a 3/2 power. Now all we need to do is distribute and combine like terms. So when I distribute, I get 6x plus 18 minus 3x minus 6, which would give me 3x plus 12 in the numerator, and the denominator is the same. And that is my second derivative. I can factor out a 3 right here, but I don't have to. So let me clean it up so that I can now do my second derivative sign chart. Okay, so now I just need my second derivative sign chart, finally, after all that work. So set the numerator equal to 0, and we would get x equals -4. Set the denominator equal to 0, you get x equals -3. So I have a -4 and a -3, and I now need to check the sign surrounding it. But there is a little bit of a glitch. There's something I should have done right when we started this problem. As soon as you see a square root in a problem or a natural log in a problem, you have to think you cannot take the square root of a negative number and you can't take the natural log of a negative number. So right away when you start this problem, you should think, what's going to make this equal 0? And make sure anything that creates a negative number under there, you get rid of that. So this will be 0 when x is -3, but less than that is not possible. So if you think about it, if I plugged in for x a -4, then you'd get the square root of a negative number, which is not possible. So basically go to -3. Anything left of -3 really doesn't even exist on this graph. It's literally impossible. So now you only have to consider the right side of -3. So I'm going to plug in a 0, and it turns out the numerator and the denominator are positive. Okay, so this graph basically is only concave up. It is not concave down, and it is concave up from -3 to infinity. And I would say, go ahead and graph this function and look at it on your graphing calculator so you can see what it looks like.